Hello my dear, in this lecture I'll discuss marking reaction forces in a free body diagram. Marking reaction forces in a free body diagram not only creates problem for students of 11th, 12th and competitions, but also to the students of engineering too. I will tell you a mechanism which is so simple that its simplicity will simply mesmerize you. The only basic information required to handle this is that reaction forces always act perpendicular to the surface which supports the system. To understand the mechanism, let us take 1-2 simple examples and then we will go for the complicated ones. Okay? Now, let us have a situation in which a book is lying on a horizontal table. You can also have another situation in which a block is resting on an inclined plane. As soon as you are in a situation, you simply try to think that in which direction the motion of the system is restricted. Supposing in this case, if we look carefully, we can see that the book can move towards left or the book can move towards the right or the book can move upwards. The motion of the book is restricted in the downward direction. That's it. As soon as you recognize the direction in which the movement of the system is restricted, the reaction force will be acting opposite to the direction of restriction and obviously on the system. That is, in this case, the reaction force will be acting like this. Similarly, if you look at this case, again you can see the block can move in this direction, the block can move in this direction, or the block can move in this direction, but the block cannot move in this direction. That is, motion along this direction is restricted. So, the reaction force here will definitely act perpendicular to the surface which supports the system opposite to the direction of the restriction. You can see here, isn't it? So, this is the direction of the reaction force. Now, let us have some complicated examples. Like you might have a block which is lying over another block lying on a horizontal table, or you can have a stair resting on the wall, or you can have a sphere lying in a conical groove, let us say like this. Or you can have a sphere hanging from a vertical wall, or you can have a beam or a rod supported by knife edges. You can think about any number of situations you wish. The mechanism will work in each and every case. Supposing here, in this case, we choose A as the system and we are supposed to mark the reaction force on A. You can easily see that the movement is restricted in downward direction because the block can move in this direction or in this direction, isn't it? So the reaction force on block A will be acting like this. Let us say this is point B, this is point C. In this case also you can easily make out that the restriction is in this direction and in this direction. So these are the directions of the reaction forces, isn't it? Here also you can make out the restriction is in this direction and in this direction. So the reaction force will be acting like this. So this is the point D and this is point T. So RD, RE. Here also apply the same mechanism. This sphere can move upwards, it can go downwards, it can move thiswards, isn't it? But it cannot move this way. So naturally the reaction force will be acting like this here. In this case also you can see that the restriction of the beam is in this direction downwards. So naturally the reaction forces will be acting like this. See, it is so simple, marking the reaction forces in a free body diagram. Here I have intentionally not taken the system as a point so that you can clearly see what is going to happen. Now, to make it even simpler, I will tell you a trick, a magic trick, isn't it? When you are supposed to perform a magic, you need some magic words like abracadabra or gilly gilly, something like that, isn't it? Here the magic word is vanish support. In any situation you are in, just vanish the support and you will immediately know in which direction the reaction force is going to work. Let us try and see whether this magic works here or not, isn't it? In the first case, the book is lying on this horizontal table. Now say the magic words, vanish support, vanish the support, isn't it? So immediately you will see that as soon as you vanish the support, the reaction force will be acting on block A in the upward direction. In this case, just vanish the support. The reaction force always acts perpendicular to the surface which is supporting the system. So here the block B is getting supported by this inclined plane, and as soon as you vanish the support, immediately you see that the reaction force will be acting perpendicular like this, isn't it? Similarly here, you vanish the support. If you have chosen A as the system, you vanish the support. You can clearly see the reaction will be acting like this. In the staircase also, you just take the support out, throw it away, vanish the support, and you can immediately see the reaction forces will be acting like this. In this case, take the cone, the groove, drop it. Just drop it, man, and you will simply see that the reaction forces are acting like this, perpendicular to the point of contact, naturally on the surface in which this sphere or cylinder is lying. Same way here also, this sphere is being supported by this wall, When is the wall? As simple as that. Remove it, isn't it? You can immediately see that the reaction force is acting here like this. In this case, when is the support? And you immediately know where the reaction forces are working. Isn't it? See, the magic works in each and every case. Now, don't tell me that it can be simpler than that. Isn't it? It can't be. Enjoy.